maximum velocity with which a car can go round a curved path and the path is rough. In the diagram, this is a rough curved road. O is the center of this rough curved road. We can denote the radius of this curved road. Here R will be the radius of this curved road. This is the radius of this rough curved road. R is the radius of this curved road. This is the curved road or path, and this curved road is rough. Now we can draw a car and which will be taking a turn around this rough curved road. We can denote the weight of the car. Mg is the weight of the car which acts vertically downwards, and there will be normal reaction force on the car applied by the road. R is the reaction or reaction force on the car applied by the road. This is the imaginary curved path along which the car will be taking a turn around the curved road. This is the imaginary curved line along which the car will try to take a turn around the curved road. Now we can denote the tangential velocity of the car with which it will try to go around the curved road. V is the tangential velocity of the car. V is the tangential velocity of the car. Now the car has a tendency to move radially outwards. When the car is taking a turn round a rough curved road, the car has a tendency to move radially outwards, and this is the direction of tendency to move. This is the direction, and as the car has a tendency to move radially outwards, kinetic friction Fk will act radially inwards, and in this case kinetic friction Fk will supply necessary centripetal force Fc for the revolution of the car round the curved road. When a car takes a turn round a horizontal curved path under bracket rough, the curved path is rough with a tangential velocity, comma, it will have a tendency to move. It will have a tendency to leave the curved path and regain its linear motion radially outwards. Hence the kinetic friction under bracket Fk acting between along between the wheels of the car and the rough curved road will act radially inwards. The kinetic friction acting between the wheels of the car and the curved road will act radially inwards. Now, this kinetic friction or force of kinetic friction Fk, this kinetic friction Fk will provide necessary centripetal force Fc. This kinetic friction Fk provides the necessary centripetal force Fc for taking a turn, will provide the necessary centripetal force Fc to the car for its revolution round the curved road. Therefore centripetal force will be less than equal kinetic friction Fk, or mv square by r less than equal mu r, where kinetic friction Fk is equal to mu r, where the reaction force on the car applied by the road is r, and r is equal to mg, or mb square by r less than equal mu into mg, mb square by r less than equal mu into mg, and in this case normal reaction force R is equal to mg. We get v square by r less than equal mg. Then finally we get v as equal root over mu rg. V will be less than equal root over mu rg. That means maximum value of velocity, that will be v max, will be root over mu rg, where mu is the coefficient of kinetic friction, between the wheels of the car, and the curved road, Vmax is equal to root over mu rg, that is the maximum velocity with which a car can take a turn. Vmax is equal to root over mu rg, that is the maximum velocity with which a car can take a turn round a horizontal curved road, and the horizontal curved road is rough road. The horizontal curved road is made rough so that the required centripetal force will be supplied by the force of kinetic friction. That means the centripetal force Fc is supplied by the kinetic friction Fk, and maximum velocity with which a car can take a turn, that will be Vmax equal root over mu rg. Vmax is equal to root over mu rg.